Welcome back. This time around we're going to have a go at getting the RAM floppy drive for the Z80 system working. That's this one here. So yeah, let's get into it. So the first thing we need to do to get the RAM floppy card actually working is compile a ROM image that has the drivers in it that support that card. So yeah, let's jump over to the PC and we'll make a start on that. So the first step towards building a new ROM for this system is of course to download the code, and that's available on GitHub. It was put together by Wayne Worthen. Hopefully I pronounced his name correctly. So we'll copy the link to clone it, the HTTPS link, and then we will go to the machine we're going to do the build on, and we go git clone, and we'll paste that in. And it'll download the image. Now something I did find, I was playing with this the other day, and I was going to use a Raspberry Pi as the build environment. Well, that worked well until I got to the actual build, and in the build is some code to do with a propeller chip, which I think is used for a video display card. Not that I've got one, but it's used for that. And the utilities that compile or assemble the code relevant to that aren't available for the ARM architecture. So yeah, so I ended up moving to an Intel box, which is the box I'm doing this on now. So we've got our code. I think at this point we can just do a make, I think. I'll go into the directory, and I think we can do a make, and that will build the necessary toolkit and necessary tool chain to build the rest of the ROM. In fact, this may even go through and build the entire thing. So I'll just fast forward through this because this is going to take probably a few minutes. Right, and at this point, it's built, I believe at this point it's built the disk images and all the tool chain and what have you. And it's asking us specifically which platform we want to build this ROM image for. And as you can see, it supports quite a few. In our case, we're going to go for the SBC. And we'll just go standard for the moment because we're going to create a custom configuration file in a minute and build a ROM image specifically for that. This is just building a standard ROM. Right, so I thought it was actually the last part of the build before we selected the SBC that had built the disk images, but looking at what it's just done, I'd say it was this last bit that actually built the images. So at this point, we'll go into, I think it's the source directory, hbios config, and I've already got a config file that I've built previously, so I'll just copy that. I think it's SBC Bob, and we'll copy that into the config directory. So if I go back out to the hbios directory, I should be able to go make, and it'll make just the machine specific part of this, and the SBC, and now we've got Bob listed in there, so we can select that. And this will be a lot quicker because it's already assembled and built a lot of the things that it needed to do. And there we go. So we should have in here somewhere a ROM image. Yes, we do. We have a 512K, that's 512K, SBC underscore bob.rom. Right, so at this point, I should be able to actually use I think, Z modem to download that to my PC. I mean, I could SCP it from the Linux host. I could FTP it. There's any number of ways I could get it off, but Z modem is good as any. And it's done. It was literally that quick. Although it says 37 kilobytes, and that is not right. Oh, sorry. I transferred sbc_bob.com. I want .rom. My bad. Right. So we've transferred 512 kilobytes, and that was quick because that was Z modem happening over Ethernet, and gigabit Ethernet gets pretty quick. So now we can go to the Z80 machine itself, and we'll turn it on. We haven't, of course, put the ROM on it at this point, so it's running the old version of the ROM, and we don't have the RAM floppy card in it yet either. So we're going into Z system. I've got a floppy disk in the floppy drive, which I believe is it's got the flash utility, X modem utility, and otherwise it's got I think about 1.4 megabytes of space free. It's a 1.44 meg floppy. So D, we can go XMR. We'll call it new.rom. And transfer, send X modem, downloads, and there's the ROM. And that'll take a little while. Okay, so that's done. Of course, the serial line can go roughly 3 times that speed, well, 3 kilobytes a second. The slowness basically arises from it writing to the floppy drive. That's the only storage I've got on this machine other than RAM disks, and the RAM disks aren't big enough to put a half meg ROM image in, so I have to store it on floppy drive. Yeah, that's what slows it down. So if we have a look at the directory, we can see our new ROM. So go flash, just look at the help. So flash, write new.rom. And as far as the options, we're going to write the whole ROM, and we don't need to force any particular type of bank switching. The default ROM WBW bank switching is the correct type for this machine. So we should be able to run this and have it just work and have it rewrite the ROM. Fingers crossed. Feel free to drop a comment if you think it's going to work or not. So it says there it's reprogrammed 121 of the 128 sectors. That's because 7 of the sectors on the flash chip didn't change, so there was no need to rewrite them because nothing had changed. At least that's my understanding of what that means. Okay, so in theory that's done. The next step, which we'll do in a minute, is to repower the machine and boot into the new ROM. Now, if this doesn't work, if there's something wrong with this ROM image and the machine just doesn't boot, then the way to fix that is to pull the flash ROM chips out of the board and use the TL866 to program a new image on that way. So it's recoverable if it doesn't work, just not a particularly fun process. And of course, I just realized that I didn't actually show you what was in that config file that I used. So let's have a look. SBC, I'll actually use my other editor, SBC Bob. Right, so this is a lot more verbose than the standard config, but I don't know, this is just my preference. This is how I do it. Now, somewhere down in here is the flash floppy. I don't remember where it is. Where was it? Let me find it. Can't be that hard to find. RAM floppy driver. So that's, I believe, it here. We've enabled it, and we've got one RAM floppy unit. I believe that is correct for this card. I assume assumptions that one unit is one card, and not that it, I mean, it could be that one unit equals one virtual floppy drive. Well, we'll see. We'll see how this works. So anyway, that's the config file, and it's got a few other options enabled in it for the floppy disk card and what have you that I've got. So yeah, anyway, we'll jump out of that, and yeah, we'll go back to the SBCs, or the Z80's terminal session, and give it a reboot. Okie dokie. So the Z80 is right where we left it off. We will turn it off. Fingers crossed. We'll turn it on. And let's see what it does. I've got the IDE configured in this ROM, and I didn't have that in the previous one, so hopefully this is going to time out. I don't have the RAM floppy card installed yet either. Please time out. The IDE and floppy controller I've got is a parallel port IDE. It's not the actual IDE, so I didn't actually need this option enabled in the ROM, but I have got it enabled, and yeah, hopefully it's going to time out here in a minute. Otherwise, we could be up for putting the old ROM image back on using the TL866. Come on. No. Oh. Okay, so I don't know whether that was me hitting a key there that made it skip that, or whether it just timed out. I'm not sure. But anyway. So yeah, there's our RAM floppy. It's got the devices reserved for it, but the card itself's not installed yet, so they will not be working. Okay, this is a newer version of the ROM too, so the boot, the text when it boots is slightly different. So again, Z system, see what it gives us. It's interesting because formatting the RAM disk was pretty quick with the old ROM. So we can actually update the ROM directly from the boot menu as well. I forgot you could do that. You don't actually have to download it to a floppy disk like I did before. You can flash it directly. Completely forgot. Doesn't look very happy, does it? What's it doing? Ooh, it's very unhappy. It has locked up. I wonder if it's that IDE. It should be trying to format this RAM disk, MD0. I might, oh, and I've got the SD card support enabled too, because I am building an SD card. I wonder why formatting the RAM disk's not working. I wonder if that's tied up somehow with this IDE that's not playing nicely either. I might have to build another ROM image without the IDE. So we'll leave that doing its thing, and we'll jump back to the Linux box and build an image without the IDE. Okay, so we're back on the Linux box. Got our config file loaded up. Let's just go down to where the IDE enable. False. And I believe that will disable everything else. So we'll click out of that, make SBC Bob and we go SZ SBC Bob.rom. Right, we've got the new ROM on my local PC here. Oh, look at that, it got there in the end. Okay, I don't know why that took so long. Maybe, I don't know. Anyway, so can I boot this from here? I don't know whether I can. I don't know whether I can reboot it from the command line. I'm just looking through to see if there's anything that looks like a reboot. I mean, I'm sure I can. Like, I could use something like DDT probably to upset it in such a way, or jump to a particular address that would cause it to reboot. But I'm not that familiar. So let's turn it off and turn it back on. Now this is still going to get hung up on the IDE because we haven't put that new ROM on yet. So I don't know whether... No, must have just timed out last time because I hit the same keys I was hitting last time. It hasn't skipped past it, so that's okay. It's interesting looking at the RAM floppy driver here. I've got 4 I/O addresses, and the first 2 are marked as having write protect off, and the second 2 are marked as having write protect on. So it'd be interesting to see what that does once the card's actually installed. Okay, so again, we're back here. We go H for help. Oh, list ROM applications. Yep. We can go X modem flash updater. Now, how do we do this? I think we're pretty... begin update. Yep, begin update. Start transfer, send X modem, downloads, and there's our ROM. So this will probably be a bit quicker since it's not using the floppy disk and it's going straight to the flash memory. So this will probably be near the capacity of the serial port. Maybe, maybe not. Okay, well that's done. It was a little bit faster. I mean, 3 minutes 55. I can't remember what it was last time, but it didn't seem like it was much faster. Anyway, from this menu, we can go reboot. So at this point, we should reboot and not get, and we didn't get stuck on the IDE. And the RAM disk formatted at its usual speed. So the formatting RAM disk thing, I'm guessing last time around it actually formatted the RAM disk, and the next step was where it got stuck. So at this point, if we do a dir E, which is our first RAM floppy, I'm expecting it's going to throw an error because the card's not even there. Okay, that's interesting, because the card's not even there. Let's just copy a file and see what it does. Directory full. Well, I guess that makes sense because there's nothing there. Okay, so it says it's got 4 meg, but there's no card there. Interesting. I wonder what that's about. We'll park that. Let's just power it off and we'll put the card in and see how it works. Okay, so here's our card, and I'm going to put it into the slot, probably right next to the CPU, because why not? Slide that in, push it home. Now I'm going to have to quickly pause and read the instructions because I can't remember what this switch does. I think it's a write protect switch, but I'm just going to have to check that, so I'll be back in a minute. Okay, so the card's in, and I believe the upward position on the switch enables us to write to it. So let's turn the machine on, see what happens. Right, well, our RAM floppy is showing up 4 RAM floppies, which is interesting because I did compile the ROM to support only 1, and it's showing 4, so I'm not quite sure what that's about yet. Right, so have a look at the no file, but you're supposed to do a clear directory on E, yes, and it'll still be empty. Oh, okay, that's interesting. So I'm guessing if I do something like this, it's not going to work. Nope. Interestinger and interestinger. So on the floppy, I've copied over some diagnostic code, this RAF113. See what this does. All right, so this is wanting us to use the scope to check a few things. Let's just, not quite sure what, that must be the value of the status bits coming back from the card. If I change the, don't know. If that's what it was, I would have thought that changing the write protect switch would have changed that value from a 7, but it didn't. Interesting. Oh, yeah. Test read write error track and every track. Okay, so we're not off to a flying start. Okay, I'll let that do its thing. Okay, so I've got the code here for the test program that we're running. So it's expecting the card at A0, which is where our card is. Welcome message, and we're doing a test for IC17 pin 19. That doesn't sound right. I don't think that's what it said when it started up. We'll have a look at that in a minute, but yeah, it's just doing ins and out, IO ins and outs to create a high-low pulse that we can check with the scope. So I guess we should work through these various tests and make sure everything is all right. So let's just check this. So message TS1, the messages are at the bottom. Message TS1, test low pulse at IC9 pin 19. That's, the comments in the code said IC17. I'm sure. Oh, why do I feel like I'm going down a rabbit hole today? I think that's where I'm headed. So I've got the schematic here, let's have a look. So IC17, where is 17? Oh, over the right. Right, so IC17 looks, yeah, that's related to the IO port decoding. So that's pin, right, that's the output. So IC17 pin 19 will tell us if the Z80 is trying to write to the IO ports for this card. What is IC9 then that the text message tells us to check? IC9's over here. Pin 19. So this is a different signal again. So this is if we're reading or writing to the first of the I/O ports for this card. That's coming out of this 74 LS139, by the look of it, which is driven by 2 address bits, and this RAF signal, which is what's coming out of the decoder over here. Okay, so they're basically having us check the same thing, whether it's IC17 or IC9. 17 is just a bit earlier in the chain, and IC9 is after there's been a little bit more decoding going on. So it wouldn't hurt to check both, I guess. So yeah, let's set up, I guess, and we will do that. Okay, so I've got it set up. Just move my chair out of the way. We'll run the test program. So this is where it's telling us to look for low pulses at IC9 pin 19. So we'll start at IC17 pin 19 first. Just got to find where IC17 is. '17 is next to the switch. It's this one here. And we want pin 19, so around the other side. And I'm getting absolutely nothing on the scope. So that would imply it's not even selecting the, well, that would imply that the software may well be driving the I/O port, but we're not decoding it or not detecting it as a valid port, or not detecting as the port that relates to this card. Interesting. We do have our switches set correctly, I think. Let me just check that. So 7, so on, it's actually backwards. So on is 0 bit because the port address bits are pulled up by pull-up resistors, so you have to set the switch to pull them down to 0. So we actually want 101000, which is what we want for A0. Interesting. I wonder if these switches aren't right. So we're back onto pin 19. I'll start this end because it's easier. Nothing. Nothing. No. What's going on? What goes on here? That is IC17, isn't it? Just looking at the IC17. Yep, that's IC17. It's a 20 pin chip. Pin 19 is over here. Got the right probe on the oscilloscope. Yep. Just change the position here. So we've got about 4 volts. So it's being pulled high. Oh, sorry, this is the output from the chip, so this is high. And we're looking for lows, but
actually right at the top of the tank.
Right, so it helps if you actually put the oscilloscope probe on the right chip. It's not this chip here, it's this one here. And we have no action whatsoever. So this card isn't being selected, which would imply that these jumpers are wrong. And it's, we'll start with this one, the least significant. Whoa. Okay. Interesting. I'll have to look up what that is in a minute. We'll just try the others just for giggles. Nothing. Nothing. Yeah, I don't think these will be affected, but yeah, this first one. And we start getting our low pulses on pin 19. If we go to pin 19 of the 745, which is up here, we get our low pulses as well. So what is that? So if we go to here, what address is that? So if we flip the low 101.00 A4. So with the card set to A4, we're getting the decoding that we're expecting. So our test code is set for A0, but our card is apparently responding on A4. You're what now? Well, this is the source code for the thing. What else have we got here? PRN, that's probably the printout of the assembly process. Hang on a minute. So the base address when it was built, when the utility was built, was A4. Hang on. What gives? Use HXD. Open. Downloads. Right, let's see what we've got here. So, get rid of that. Tidy this up a little bit. This is the print file. So, we'll go down to where our tests are. Right, so at 116, which will be offset 16 from the start of the file, 16, yeah, look at this, DBA4, D3A4. So the binary for the test, like the test binary, expects this to be configured on port A4, not A0, as the source code said. So yeah, talk about going down a bloody rabbit hole. So yeah, IC9 pin 19, that was the 245, so, oops. We're definitely seeing the low pulses there, so that test is okay. What's the next one? Test pulse at IC13A pin 4. 13A, whoops, where are we? 13A, where's 13? The board, not the board. 13, that was one we were on just before. 13, it's the 139. So it's this chip here. And we want, what did it say? It said we want pin 4. So pin 4 will be round the other side. Let's see if I can even get round there. 1, 2, 3, 4. Right, we're getting low going pulses there. And IC13B, same IC, pin 12. So 16 pin chips, there's 9, 10, 11. I'll go in the socket because it's easier if I can see it. 12, and I'm getting absolutely nothing. So, yeah, I'm on the right pin. We're getting a grand total of nothing. So, let's just have a look at the circuit diagram. Where is this 13B? There's 13A. Look down this middle. 14, 13, 18, 19, 19, 18, 15, 23, 16. So there's no 13B over there. 16, 19, 16, 17, and these are just our RAM chips over here. 9, 10, 11, 12. There is no 13B. I've got the board here. 13B. So 13 is this one here. Yeah. 13 is this one here. 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11. In fact, nothing on this side of the chip connects to anything. Same chip. Yeah, so pin 12, 9, 10, 11, doesn't connect to anything. So why is it telling me to... Oh, another rabbit hole. Yeah, it doesn't connect to anything. Onya. So there's no point us doing that test because pin 12 is not connected. But we were getting what we're expecting on pin 4. 13B pin 11. Well, same deal. There's nothing connected to pin 11. And IC10 pin 11. What's IC10? Where is IC10? IC10. Ah, down the bottom here. It's the one I was incorrectly probing the first time. So IC10 is that one. And what do we want? Pin 11. 11, it's a 20 pin chip, so pin 11 is going to be around the back here. And we are getting pulses at about 5.3 kilohertz. So that should be good. Test pulse at 13B pin. Well, again, nothing's connected to that whole side of IC13. And IC11, pin 11. IC11, pin 11. Oh, it's the bottom one. Same pin. I was on the right pin, wasn't I? 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11. Yeah, no, I was on the right pin. So we should be getting something on pin 11 of this one. And we are getting low going pulses there at about the same frequency. Good. Right, so that's all good. Right, so now we're looking for 55 hex on IC10. We need the IC10 is the second one in. Schematic IC10. Be one of these up here. 10. So we're looking for 5.5. What side are we looking for? Does it say? Nope, doesn't say what side of IC10 it wants us to do. So I guess we'll try both. 5.5, so pin 3. So pin 3, 1, 2, 3. Okay, this was pin. This is IC10, isn't it? So IC10 was this one, and pin 3, and we got quite a bit of happening there. So how am I supposed to find my 5.5? Oh, maybe I'm supposed to be looking at the output side of it, because the input side is going to be the data bus. And we want the latched one, so we want pin 2. Right, so that's high, so that's 1, and then pin 5, 1, 2, 3, 4. That's low. This should be high, yes it is. Pin 9, so that's, what pin was that? 6. Pin 9 should be low, and it is, so that's our first 5. And then pin 12. Pin 12 is a low bit, so that should be high, yep. 15, 12, 13, this should be low. 16 should be high. Yep. And 19 should be low. Yep. So we're getting our 5 being latched by IC10. So that's a good thing. Now I've got to make sure, do the opposite pattern on the same chip. Make sure we don't have any stuck. Make sure we don't have any stuck pin. So we want, so we're looking for A, so this should be 0101. So okay, so we've passed those tests, and now we're displaying the, I assume the 0F is the status nibble that the CPU can read to determine the status of the card. So let's see if I flick the right, oh yeah, if I flick the right protect switch, I can see we're toggling the low bit every time I flick the switch. So that's good. Okay, so I hit enter there, and you read write errors. I wonder if this write protect switch is working the opposite of what I think it is. Hey, look at that. Okay, so it's write enabled when the switch is in the downward position and the red LED is off. If I put it in the other position, I start getting read write errors. So that's write protect, and the red LED is indicating that it's write protected. Sweet. Okay, so with the write protect in the correct position, we have a completed test. So in theory, I should be able to do CLR, we'll go to drive B, CLR, DR, so clear directory on drive F, because this card is currently jumpered as the second RAM floppy card, and I should be able to copy everything off B to F. And it's working. Okay, and we've copied everything from the B drive to the F drive, and I should be able to go to F. Yep, and there it is. So if I go to the F drive and I run survey, beautiful, there it is. So we appear to be working. So it appears we've got it working. The only catch is it's showing up as the F drive, and it should be E drive. And that comes down to the jumpering of the board. So what I'll do here in a second is I'll turn the machine off. I'll pop this card out and put it in the slot that I want it in. And when I do that, I'll set the jumpers so that it maps to IO port A0, and then it should appear as drive E. So let's do that. And we'll just carefully pull the card out, and I'll change that jumper there. That was the one that the number one. That should set it to A0, which should make it drive E. Put it in the slot that I wanted it in. Push it back in. And now, when I power it back up, it should be drive E. Right, so we boot it back up. And if we go to E, yes, copy star to E. And there we go. Now it's drive E. So a lot of that messing around was caused by the diagnostic software, the compile or the assembled version not matching the source code. So that was confusing. So it looks like we've got a working RAM floppy board. The one thing I didn't clarify about this board actually, which I should have clarified at the start, was this is not a RAM disk board. This is a RAM floppy board. So it's not a pool of memory in like the processor's address space that can be mapped into a RAM disk. Although I do have one of those, that's not what this board is. This board is basically emulating, well, they call it a RAM floppy. So a very large 4 megabyte floppy disk with 512 byte sectors. Although as I think about it, that sounds more like a very small hard drive than a very large floppy drive. And I think that the project description of it describes it sort of as a precursor to a modern solid state drive. It does support a battery backup. The battery backup doesn't go on the card itself. It goes, I think, on the back plane. I don't have that at this point, but well, I might. So yeah, we'll see how that goes. So that's one more part of the Z80 system built. I've got a VGA card coming up. That's just been waiting on parts. I think, fingers crossed, that I found the last of the parts I need for that. It's mostly built. It's just waiting on about 3 components. So all going well, I hope to have that sorted in the next couple of weeks. And I've also got a dual SD card adapter to go in. That's waiting on, if I remember correctly, the actual SD card, the slots the SD cards go in. I've got some here, but they don't appear to quite be the right ones, so I've got some others on order. We'll see how that goes. But anyway, that's where we're at for now. If you enjoyed this, then feel free to tap the like. Costs you nothing to do that, and yeah, leave a comment if you've got any suggestions. The algorithm loves comments, and yeah, subscribe if that's your thing. And yeah, hopefully I'll see you for the next one. Cheers.